All right, so in this video, what we'll do is we'll do a couple of exercises from you all's textbook. So we're on page 708 in your assigned textbook, and I'm going to start with number 8, which says in exercises 1 through 8, find the distance d between the points P and Q. And they give us 2 points. They give us the point P is e to the x and 0. So this is our x coordinate, our y coordinate, and our z coordinate is 2 root 2. And then the point Q is 0 e to the negative x, and then the square root of 2. All right, so they say find d, the distance between the points P and Q. So remember, in our last lesson, I told you that we may represent the distance between P and Q as this, or you might see it represented as d. So either one is the same thing. I tend to use this because it specifies what points we're using, whereas if you use d, it doesn't necessarily specify which points that you're actually using. All right, so this equals, so we had this formula from in the last lesson. So e to the x minus 0 quantity squared plus 0 minus e to the negative x quantity squared and then plus 2 root 2 minus root 2 quantity squared. So this equals, now I often tell students, now you would simplify, of course, from this line. I'm going to simplify this a little bit more than I would require of you all. I tell students don't simplify unless you're absolutely told to, or you need to use it in the next step of a problem, because we don't want to make a mistake in simplification unnecessarily. So this is e to the x squared, which is just e to the 2x. And then this is negative e to the negative x, that quantity squared. So when we square the negative, of course, that goes away. And then we have e to the negative x, that squared gives us just e to the negative 2x. So actually, I'm going to put that at the end just so you can see something a little bit, see what I do here, maybe a little bit clearer, possibly. So this right here is 2 root 2 minus 1 root 2, which just gives us 1 root 2. So root 2, and then we square that, just gives us 2. So plus 2, and then this term I said I was going to put it in a different order and put that at the end. So plus e to the negative 2x. And most of the time you're perfectly fine stopping right here. I'm going to simplify this a little bit more because later on, say we might be doing a problem where we had to integrate something like this. You're going to run into an issue with this square root there and having to integrate this. So if we simplify it, we can make our lives a little bit easier. Now this, right, this quantity that's underneath the square root, that is itself a perfect square. That is the perfect square, e to the x plus e to the negative x squared. Now, when would you know to do something like that? Is like I said, if you run into an issue like, okay, I have to integrate something, and you know that you've done your steps correctly, but you're not able to figure out how to integrate it, you look at trying to simplify, and maybe that would help. So it may not be natural to you to see that that does reduce to this, or that these are the same thing. So you would go through and you can see that, okay, well, this is a perfect square, and this right here was a perfect square. They both came from right there. So if we try to, if we look at those terms, that the perfect squares, the things that we squared to get those terms, excuse me, and we tried those things. So I work with e to the x and e to the negative x, which are the things we use. See what happens if I take the sum of those and square. Will it simplify to this? And indeed it does. So you can go through and check that if you square this, you will actually get that. And now I can get rid of my square root with that square, and this actually simplifies. But at this stage, if you were to stop on this second line, I'd be perfectly content with that. You don't need to simplify it all the way down here right now. It just may work in your favor a little bit later on in the course. All right, next we will look at problem 18 in that same section. So number 18 says, let P be equal to the point 303. Q be equal to the point 21, -1. And R be equal to the point, sorry, I'm using the wrong points. I started looking at number 17. So Q was supposed to be 20, -1. And then R is C12. So C, just the letter C, comma 1, comma 2. Determine the two values of C that make PQR a right triangle with hypotenuse PQ. So find the two values of C that make PQR a right triangle with hypotenuse PQ. All right, so now we go into our toolbox of things that we learned before we got into this class. A right triangle, we oftentimes will think of the Pythagorean theorem immediately when we hear a right triangle, but we know our hypotenuse should be PQ. So now we would want, according to the Pythagorean theorem, the length of PQ squared to be equal to the length of PR squared plus the length of QR squared. Now remember, this notation just means distance, but that's the same thing as the length of that side of the triangle would just be the distance between those 2 points. So now we're going to go through, find these distances, put the necessary information into this formula, and then we should have something that we can go through and solve. So the distance between P and Q, start there, is the square root of, so here I'm going to do this a little bit faster now. So 3 minus 2 is just 1 squared, so we just get 1. And then plus 0 minus 0 squared, which just gives us 0, so we'll skip that. Then 3 minus the -1, so 3 plus 1 squared, which gives us 16. Well, I had way too much space there. So we get the square root of 17, but remember we want PQ squared, so PQ squared now we have is 17. And let's go ahead and find PR squared and QR squared as well. So PQ squared, which is our left-hand side of the Pythagorean theorem. Oops, sorry, you can't see that. Is the left-hand side, this is just 17. Then the length of the side PR, or the distance between PR, and let's go ahead and square it now. So if we put we're using the distance formula, but we're going to square it, which means we can just drop our square root. So P and R, so that's 3 minus C, quantity squared. And notice I don't have the square root because I'm squaring the distance, plus 0 minus 1, quantity squared, plus 3 minus 2, quantity squared. Which just gives us 3 minus C squared, and then plus, all right, we'll just do it this way. That gives us C squared minus 6C plus 9, and then here's plus 1, and then here's plus 1. So here we get C squared minus 6C plus 11. All right, now we'll go and we need to do QR squared. So QR squared, we get 2 minus C quantity squared plus 0 minus 1 quantity squared, which just gives us 1, plus negative 1 minus 2 quantity squared, which just gives us 9. So that gives us C squared minus 4C plus 4 plus 10, which gives us C squared minus 4C plus 14. All right, so now with PQ squared, the distance between P and Q squared, the distance between P and R squared and the distance between Q and R squared, we put all that into the Pythagorean theorem. And now we have the left-hand side is 17 equals, we're going to go ahead and add these two. So C squared plus C squared, because we're adding those two, which means we add these two quantities right here. So the C squared plus C squared gives us 2C squared. The negative 6C minus the 4C gives us negative 10C. And then the 11 plus the 14 gives us 25. All right, so now this, what our problem said, find the two values of C that make this a right triangle with hypotenuse PQ. So now if we solve this equation for C, then we will have the two values of C that will give us that right triangle. And now to solve this for C, I'm not going to go through and do it. I'll let you all finish that part off. But all we're going to do is you can use the Pythagorean theorem. So this is 2C squared. I mean, not the Pythagorean theorem, the quadratic formula, sorry. This is 2C squared minus 10C, then the 25 minus the 17, bring that over to the other side. Gives us 8 equals 0. And now on that, you can use the quadratic formula and solve for C, or actually you can factor out that 2 and see if that factors to solve for C, and you'll get your two values that you would use for this C right here to make a right triangle out of those 3 points. All right, so now we're not looking at this geometrically, although it's a geometric problem. I'm not having you all look at it in the coordinate axes, but if you wanted to, you could try to sketch, once you find the value C, if you want to, just for practice, you could try to sketch the point 3, 0, 3, 2, 0, negative 1, and whatever one of your C's is, along with 1, 2, and then sketch a little triangle just to practice sketching stuff in 3 dimensions, since it's something that is new to us.